early humans, Earth was the center of the universe. But then during the Middle Ages, scientists proved that the sun, not our planet, was at the center of a system of moving heavenly bodies. A solar system of planets that during the last half-century has had many of its secrets revealed through astronomy and space exploration. Astronomy, Part 1, Exploring the Solar System.
Scientists consider astronomy the study of the universe, that is, space and all the objects in it, the planets, stars, different kinds of satellites, and any other bodies. Man has always been fascinated by the heavens. The first space scientists, known as astronomers, gazed at star-filled skies and, using their imaginations, saw constellations shaped like animals and mythical gods. Now, spacecraft, computers, and powerful telescopes have vastly expanded our window on the universe. In this program, we'll see how modern astronomers explore space by using telescopes, satellites and probes, and manned spacecraft. Then, we'll discuss our solar system, visiting first the planets, and then other objects that circulate within the system.
First, let's take a look at telescopes, the primary instruments used by astronomers. Light from the sky, from space, continues to be astronomy's main source of information about the stars and other planets. Optical or light telescopes use lenses and mirrors to collect the light from stars and capture dramatic images of the universe. The refracting telescope is a basic model of the optical telescope, used by Galileo in the 17th century, and now often used by students. With the refracting telescope, light rays are collected by a large objective lens to form an image on a lens or eyepiece. But since 1900, most large-scale optical telescopes built for professional astronomers are reflecting telescopes, like this one.
The reflecting telescope uses a concave lens to focus light on a mirror that reflects the image onto an eyepiece where it's magnified. In astronomy, increased light means greater detail, so the most powerful reflecting telescopes are multiple mirror designs, where several mirrors replace one large single mirror. Modern optical telescopes are housed in observatories, domed buildings usually on mountaintops with roofs that open in the evening. Inside the observatory, scientists use powerful computers to precisely focus a telescope on segments of the sky, and then correlate the recorded information. By far the clearest and most powerful telescope, however, is above us, the Hubble Space Telescope, which orbits Earth at an altitude of about 400 miles. Why do you think the Hubble Space Telescope has greatly increased astronomers' range of observation?
The Hubble telescope is able to record images without the interference and distortion of Earth's atmosphere. About the size of a boxcar, the unmanned Hubble Observatory was launched in 1990 by the National Aeronautics and Space Administration, NASA, America's primary agency for space exploration. Hubble is basically a reflecting telescope powered by solar energy. Astronomers analyze its cosmic data, which is transmitted to Earth by radio waves. Perched high above us, Hubble focuses far outside our solar system, where distances are measured in light years. With light traveling at 186,000 miles per second, the light from some of these stars may take billions of light years to reach us. Stars and other objects in space also radiate energy in forms other than light. Radio telescopes, like this, monitor radio waves from space, enabling scientists to detect objects beyond the range of optical telescopes. Here, for example, is a radio image of a star that exploded billions of years ago in space. Using radio telescopes and powerful computers, scientists can also scan for signals that may suggest the existence of extraterrestrial life. To increase reception, sometimes radio telescopes are arranged in formation. Radio telescopes, then, have a greater range than optical telescopes for detecting distant stars in the universe. What other advantage do you think radio telescopes have?
Regardless of weather, radio telescopes, unlike optical telescopes, can continue to function because electromagnetic energy in the form of radio waves can pass through any atmospheric conditions. To unlock the mysteries of the cosmos, though, space travel is necessary. Unmanned devices for exploring space, such as satellites and probes, have greatly increased our knowledge of the solar system during the last 50 years. Our modern age of space exploration started in 1957 when the former Soviet Union launched the first artificial satellite called Sputnik. Orbiting and transmitting signals to Earth, it was later followed by a series of American and Soviet satellites. Satellites blaze the way for probes, robot devices used by scientists to navigate the solar system. Probes like this Viking spacecraft headed for Mars are equipped with cameras and transmitting equipment to communicate with Earth. The unmanned probes may land on the surface of a planet or moon, journey past the target, or operate far into space. The Viking missions landed on Mars in 1976 to photograph and conduct experiments.
Safe and efficient, the robotic spacecraft have provided views of the Sun, nearly all the planets, and many moons. Voyagers 1 and 2 are probably the most successful probes to fly by planets. Since 1979, they have visited Jupiter, Saturn, Uranus, and Neptune. But, without a doubt, the most dramatic and informative means of exploring space is by manned spacecraft. During the 1960s, striving to reach the moon, American astronauts orbited Earth for the first time. Then, following probes to the moon's surface, the Apollo lunar missions began, with astronauts first setting down on the moon in July 1969. During the next 3 years, 6 Apollo spacecraft landed on the moon, with astronauts exploring the lunar surface and conducting experiments. In the early 1980s, the manned spacecraft effort continued with reusable space shuttles, which have been employed for numerous experiments and launching and maintaining satellites.
Scientists believe that manned space stations will play an essential role in future space exploration. The Mir space station, seen here in orbit, was launched by the former Soviet Union in 1987. Another space structure, the International Space Station, or ISS, is under construction by various countries and is set for completion in 2004. It has taken centuries for mankind to learn what we know about our solar system, and there is still much to discover. The system consists of a star, the Sun, 9 planets, more than 60 moons, and millions of other objects, including comets and asteroids. The planets and their moons revolve around the Sun in orbits that increase in size as we progress out in the system. What do you think keeps the planets orbiting the Sun?
There is an enormous pull of gravity from the Sun that keeps the planets and their moons in orbit. Indeed, the Sun's energy and gravity are so great because the Sun contains more than 99% of the solar system's total mass. How do you think the solar system was formed?
There are many theories, but most astronomers believe a nearby star may have exploded, becoming what scientists call a supernova, like the huge star we see in this view from the Hubble Space Telescope. According to astronomers, the exploding star sent a shock wave crashing through the universe, causing dust, gases, and ice in the area of our solar system to contract and spin. In a process that began more than 5 billion years ago, the spinning space material became increasingly dense and very hot. When the packed material reached a temperature of 10 million degrees centigrade, the process of nuclear fusion began, generating energy and creating the sun. Material left over from the sun's formation accumulated, resulting in structures that became planets.
Thus far during this program, we've discussed how astronomers explore space and the theory which attempts to explain the formation of the solar system. Now for a review question, go to activity sheet number 1.
To achieve goals in space exploration, scientists have made remarkable advances in technology. Indeed, many of us benefit daily from this technology. In what ways has space technology had an impact on your life?
Here's the correct answer for the exercise you've just completed. Advances in computers, battery-powered hand tools, and quartz watches have resulted from the space program. Fire-resistant uniforms and breathing apparatus used by firefighters were designed originally as flight suits for NASA astronauts. Pens, which write without the help of gravity, and sunglasses, which adjust to various light levels, are also examples of the many space exploration products that affect our lives.
Now, let's explore the solar system. Our planetary system covers a vast space. For example, Pluto, the furthest planet out in the system, is on average more than 3.5 billion miles from the Sun. Astronomers divide our solar system into 2 groups of planets, the 4 inner planets and the 5 outer planets. Nearest the Sun, the 4 inner planets are Mercury, Venus, Earth, and Mars. The outer planets are Jupiter, Saturn, Uranus, Neptune, and Pluto. The 4 inner planets are made of rock, while the 5 outer planets are mostly gas. Mercury is the closest planet to the Sun and the second smallest planet in the solar system, with a diameter about 40% that of Earth. In the 1970s, America's Mariner 10 space probe flew over Mercury, photographing its surface, which appeared much like the surface of Earth's moon with many craters. What do you think caused these craters?
These craters are caused by the impact of crashing meteoroids, rocky objects hurtling through space and hitting the planet's surface. Since Mercury is so close to the Sun and has a very thin atmosphere, the planet experiences extremes in temperature, ranging from 450 degrees centigrade during the day to minus 170 degrees at night. Venus is the second closest planet to the Sun. Sometimes called Earth's twin, the 2 planets are about the same size and mass. But Venus's dense atmosphere, containing mostly carbon dioxide, creates a greenhouse effect with suffocating conditions. Its surface temperature, approaching 500 degrees centigrade, is higher than any other planet in the solar system. The Magellan probes gathered extensive data from the surface of Venus in the early 1990s. Venus is rocky like the 3 other inner planets, but its surface is marked by intense and continuing volcanic activity.
Moving outward from the Sun, the next planet is our home planet, Earth. Scientists say Earth was formed about 4.6 billion years ago, with life first appearing about 800 million years later. Earth is the largest of the 4 inner planets. Its atmosphere with oxygen acts as a shield, protecting us from most of the Sun's dangerous radiation. The layer of atmosphere helps create a surface temperature, making possible the essential ingredient of life, water. Indeed, from space, Earth appears to be a blue planet because water covers 70% of the surface. Earth is the only planet in the solar system where intelligent life is known to exist. The nearest heavenly object to Earth is the Moon, orbiting our planet at an average distance of about 240,000 miles. Many astronomers believe the Moon was formed at about the time Earth was. They speculate that another body, possibly the size of Mars, collided with the young Earth, knocking off molten material that became the Moon.
Mars is the fourth planet from the Sun. About half the size of Earth, its rotation and length of day are about the same as our planet. Sometimes called the red planet, the dry, rocky surface of Mars is rich in iron oxide. But astronomers believe the ice caps at the planet's north and south poles contain frozen water or carbon dioxide. Since the early 1970s, various space probes have visited and studied Mars. In 1976, the Viking probes photographed most of Mars' surface, including the largest volcano in the solar system, the inactive Olympus Mons, which is nearly 17 miles high. Touching down on the planet's surface, the spacecraft conducted biological and chemical tests. Samples of the Mars soil, however, failed to indicate conclusively any sign of life on Mars. Then in 1997, the highly successful Pathfinder spacecraft landed on Mars with a robotic vehicle called Sojourner to conduct experiments and send back excellent photos to Earth. For the next 10 years, various robotic missions are planned for Mars to survey the planet and its resources, searching for clues to conditions millions of years ago that may have permitted life. With only a thin atmosphere, Mars has temperatures ranging from 35 degrees centigrade during the day to minus 170 degrees centigrade at night. This temperature difference results in constant windstorms.
Jupiter, the fifth planet from the Sun, is the first of what astronomers call gas giants, the outer planets in the solar system. With a diameter 11 times larger than Earth, Jupiter has a greater mass than all the other solar system planets combined. Several space probes have provided valuable information about Jupiter. Data from these probes indicates that Jupiter has a stormy atmosphere of hydrogen, helium, and other gases, making the existence of life virtually impossible. Under the layers of gas and liquid, Jupiter's center is probably a solid core. Visible in its atmosphere is a giant red spot. What do you think this red spot might be? Astronomers say the giant red spot is probably a storm about 3 times the size of Earth. Jupiter has 16 moons, including 2 of particular interest to astronomers. One of them, Europa, has an icy surface, possibly covering a liquid ocean. The other, Io, is the most volcanically active body in the solar system.
Saturn, the sixth planet from the Sun, is the second largest planet in the solar system. Like Jupiter, Saturn is a gaseous planet, with density so light that it could probably float in water. It's believed Saturn has a small rocky core under layers of liquid and gas, including hydrogen and helium. Scientists have guided several probes past Saturn, and in 2004, the Cassini probe will begin a 4-year orbit of the planet. Like the other gas planets, Saturn has rings orbiting its equator. These rings look solid, but the Voyager probes showed they consist of chunks of ice and rock. According to scientists, these particles probably come from comets, broken up by the planet's gravity field over the last several hundred million years. With at least 18 moons, Saturn has more lunar satellites than any other planet in the system. The largest, Titan, is bigger than Mercury and appears to be half rock, half frozen water, with a thick atmosphere including nitrogen and methane.
After Saturn, Uranus is the next planet out in our solar system. It takes some 84 years to orbit the Sun. The color of Uranus has a distinct blue-green hue, probably the result of an atmosphere composed of hydrogen, helium, and methane. According to information from the Voyager 2 probe, the planet's surface is probably liquid, consisting of water, methane, and ammonia, with a rocky core at the center. Tilted oddly on its side, Uranus has a system of very thin, dark rings and is surrounded by 15 moons.
The eighth planet from the Sun is Neptune. Voyager 2 in 1989 visited Neptune, which has an atmosphere similar to that of Uranus, but has more methane, resulting in a bluer color. Scientists say the surface of the planet is probably liquid water, methane, and ammonia surrounding a rocky core. Neptune has 8 moons.
The last and coldest planet in the solar system is Pluto. More than 3.5 billion miles from the Sun, Pluto takes nearly 250 Earth years to revolve around our star. An astronomer discovered Pluto in 1930, and no probes have thus far visited the planet. But the Hubble Space Telescope has photographed Pluto and its moon, Charon, which is about half the planet's size. Made of ice and rock with only a thin atmosphere, Pluto is only about 1/5 the size of Earth. Astronomers sometimes call Pluto and Charon a double planet, traveling through the far reaches of our planetary system.
In addition to the Sun, the planets, and their moons, the solar system has a large number of small objects. Billions of small rocky bodies, known as asteroids, are located in the asteroid belt between Mars and Jupiter. Photographed by space probes, these pieces of rock are sometimes called minor planets because they orbit the Sun. But only about 10 of them are more than 150 miles in diameter. Why do you think the asteroid belt is located between Mars and Jupiter?
Many astronomers believe that Jupiter's strong gravity pull has kept the asteroids from joining together and forming a planet. Comets provide one of the most spectacular shows in the sky. Made of rocky dust and snow, these objects periodically travel through the solar system, passing around the Sun. Many comets originate in the Kuiper belt, located near the orbit of Neptune, or in the area on the edge of the solar system known as the Oort cloud. Sometimes described as dirty snowballs, comets are composed of rock, ice, methane, and ammonia. As they speed toward the Sun, comets acquire glowing heads and tails pushed back by wind from the Sun.
Also traveling through space are many pieces of rock called meteoroids that have usually broken off comets and asteroids. When these meteoroids pass through Earth's atmosphere, friction creates a fireball, known as a meteor or shooting star. According to astronomers, about 100 million meteoroids enter the atmosphere daily, and most of them burn up. What happens when a large meteor survives the plunge through the atmosphere?
When a meteor actually hits the Earth's surface, it's known as a meteorite and makes an impact crater. Such craters are found in various places on Earth and indeed throughout the solar system on many planets and moons.
To review briefly, during this program, we've seen how modern astronomers explore space by using telescopes, employing probes and satellites, and by flying missions in manned spacecraft.
We've toured the solar system, learning about the planets, and then about comets, meteors, and asteroids found in the system.
While discussing our solar system, we've visited one very small part of a vast universe that stretches before us with infinite possibilities and many mysteries.
To review the material we've covered on astronomy and the solar system, here's a final question for you to answer. Your teacher will discuss the answer with you after the program. Turn now to activity sheet number 2, and we'll take a look at the question.
Our planet has had many encounters with space objects such as meteors and comets. Some scientists believe dinosaurs became extinct more than 65 million years ago when a huge asteroid smashed into Earth's surface. How do you think this event could cause the extinction of the dinosaur?
Go ahead now and complete the question, rounding out the program. Later, you can discuss the answer with your teacher.